AI coding has become incredibly powerful, but it's created a new problem in my workflow: the wait time. You might think it's not significant, but that's probably because you're not using context engineering methods yet. The best framework for this is the BMAD method. It's essentially a step by step approach for using AI agents like Claude Code and Cursor to build real projects. It starts with structured planning, mapping out everything before implementation begins. With this planned approach, it creates stories, tasks designed to be completed in a single run using the full 200K context window. But here's the issue. When you run these stories, they're so comprehensive that they take considerable time to execute. And today, I'll show you exactly how to eliminate this waiting problem. So the solution I'm going to show you in this video uses GitHub work trees at its core. If you're not familiar with them, they essentially copy your entire code base into a sandboxed environment where you can work independently. By giving Claude these sandboxed environments and using the BMAD method in a specific way, I can enable parallel development. This means a single large task gets divided into multiple parallel tasks, allowing multiple agents to work on them simultaneously and drastically reducing my wait time. Now, a quick break to tell you about today's sponsor, Outskill. Remember when people worried AI would replace jobs? Well, it's already happening. Companies are cutting roles left and right because of automation. But here's the good news. You can use Outskill to future-proof your career and get ahead of the AI curve. Outskill gives you free access to their 2-day AI mastermind happening this weekend, 10 a.m. to 7 p.m. on both days. Normally, this program costs $895, but the first 1,000 people get in completely free. Across 16 hours of live training, you will explore 10 powerful AI tools, master prompt engineering, build your own AI agents, automate workflows, and even create full apps and websites with AI. Over 4 million people worldwide have already attended, and now it's your turn. Plus, you'll unlock bonuses worth over $5,000 when you join both days. Grab your free seat now using the link below or scanning this QR code. To show you the demo, I'm just going to take this example project that I'm starting. I'm using the BMAD method in this. I won't dive into the complete workflow or setup process, but I will give a basic overview as you need that to understand the video. Otherwise, you'll be confused here. I have linked a detailed video on it in the description below. Even if you skip the video, I highly recommend checking it out on GitHub. It truly represents how AI coding will be done moving forward with these agents. The starting point is the PRD and the architecture.md file. These are made by BMAD's team of planning agents. The agents are bundled into one file and you can drop them into Claude Desktop or ChatGPT. I brainstormed my idea with them, which initially was to build a Mac app but evolved into a simple web app. The main goal was helping people learn Mac keyboard shortcuts through an on-screen interactive keyboard. After the whole brainstorming process, I got the two documents and put them into the docs folder. Once these two documents are complete, stories are generated based on them. Stories are essentially your project divided into big tasks that normally take developers weeks to complete. Each story contains everything required to complete a task, including the commands and where the code is supposed to be placed, since it's all pre-planned. This significantly reduces hallucination chances. These stories were generated using Claude Code, as shown here. It creates stories directly from the PRD and architecture documents, and in our case, it has been designed for parallel development, which we'll explore after covering the basic workflow. I currently have 7 main stories generated by Claude Code. After story generation, we use task-specific agents from the BMAD method. Each story is implemented by the BMAD dev agent through a / command in Claude Code. Once implementation is complete, we use a QA agent to validate the code and ensure the dev agent correctly followed its task in the story. If tests need to be run, the QA agent handles those as well. Through this way, even if errors are made, there is a check loop that can catch and fix them. If you're enjoying the content, please consider hitting the subscribe button. We try to get better with every video, and your feedback in the comments section always helps us out. Normally, with the BMAD method, I follow a step-by-step approach by doing one task at a time. The problem with this is that a single Claude Code instance is doing the whole task, which slows down the process. This is what we'll solve with this multi-agent system. Now, here's what you're going to do. We ask the BMAD story generating agent to examine each story and determine if it can be broken into multiple non-conflicting subtasks. If possible, split them into separate stories. This project originally had 7 tasks. The agent split the first story into 3 parts, the second story into 3 parts. Stories 3 through 6 stayed singular because dividing them would create conflicts. Story 7 became 2 tasks. This is how you can do parallel work with Claude Code. I'll show you exactly how much time a Claude agent took per story component. Once you see the numbers, you'll understand why this approach is essential. The BMAD method might already have this division logic built in from a recent update. I'm not certain, but I created a custom prompt for this, which I'll share in my resources. The stories are generated by the Scrum Manager agent. My custom prompt instructs it to automatically generate stories optimized for parallel development instead of just asking it to create stories. It also ensures the agent understands we're using Git work trees as the core to prevent conflicts, and that everything must merge back together at the end. I ran the SM command with this custom prompt, and it generated stories made for parallel development. Now, how do you actually use GitHub worktrees? Worktrees aren't new. Developers have used them for version-controlled software development for years. You can use them through the terminal, but there's a better way with Claude Code. I've been using Conductor. It lets you run multiple Claude Code instances in parallel using Git worktrees in this IDE with this amazing UI. Even if you're not using this entire method, I recommend Conductor with Claude Code. I prefer it over terminals or using it in IDEs like Cursor. You can also manage multiple projects in Conductor. As you can see, I have 2 projects, Mac Shorts and a test project that I was experimenting with. I've implemented 3 stories here, designed not to conflict with each other. I can complete story 1.1 regardless of whether story 1.2 or 1.3 are done or not. I could also start directly with story 1.3, but before starting, you need to have a Git initialized repository, which is also synced with GitHub. Currently, only the base version is in the repository. The 3 changes haven't been pushed yet because I wanted to demonstrate this first. That's why the repository in Cursor still only has the docs and not the app. Now here's how you can use Conductor. For the multi-part stories, copy its name, go to Conductor, and create a new workspace with it. These workspaces are new work trees that Claude will use. This creates a fresh copy of the codebase in which different Claude Code instances can work independently without conflicts. Next, initialize the dev agent using its specific command. Understanding the BMAD method is essential here. It's extensive with many commands as well. I've been using it for a while, so navigation is familiar, but there's a learning curve. It's worth the investment. Then tag the story you're working on. This is the full command for Claude Code to work on that specific story. When initialized, it spins up the full stack developer and begins working. I really appreciate Conductor's UI compared to the terminal. It makes using Claude Code much more pleasant. Even without the story splitting workflow, using Conductor with Claude Code in a Git project is an excellent experience. Now, I discovered something interesting while preparing this demonstration. Since these tasks are already completed, they only display the tool calls, messages, and commits. The actual time taken was only shown while they were running. So to demonstrate the timing for you, I ran the first task again. As you can see, it's been 8 minutes and we're on the 6th to do. When I originally ran these, the first task took around 12 minutes and the second took about the same. The third task was the longest, involving custom UI implementation. That one took between 18 and 20 minutes. Here's where the problem becomes clear. Imagine a single agent handling all of this sequentially. With the BMAD method, the setup would still be the same, but the time investment would be significantly higher. Normally, the BMAD method would bundle all of this into one large story, or at best, split it into 2 stories that would still execute one after the other. But by running them in parallel instead, I changed the entire equation. Even though the longest task still took 20 minutes, that became my total time, not the 40 minutes it would have taken running them sequentially. That's the real power of the multi-agent workflow. You're not waiting for each piece to finish before starting the next one. Everything happens simultaneously, and you only wait for the longest task to complete. Now moving on, I ran the dev agent next to start the implementation. After that, I called the QA engineer with its review story command. QA was crucial here. It caught minor concerns in this story, but in stories 1.2 and 1.3, there were major issues requiring fixes. After the QA review, I called the dev agent again. It reviewed the QA feedback and fixed everything. That's how I completed all 3 stories stories. Now let me explain why this initial setup took so much time and benefited from parallel processing. The first story was the foundation, initializing Next.js and installing dependencies. That was a complete task. Then the second story was the data layer. For this keyboard-focused project, we loaded all keyboard information and app data we needed. The UI components took the most time. It involved generating custom components from our pre-planning phase. The dev agent had to follow that plan exactly. All that was just initial setup. If a single agent had handled all three parts sequentially, it would have taken significantly more time. This was why splitting tasks and using multiple agents was crucial. It maintains quality while reducing time. After completing the story, you create a PR and ask Claude Code to merge it into the main branch. You can see the PR has been created here. It includes 104 Mac keyboard shortcuts from Story 1.2's data layer. Looking at the pull request, we can merge it. Once merged, you'll notice our data folder is now in place. I'll merge Story 1.2 and 1.3 one by one, then continue working on the second, third, and fourth stories through Conductor. The sequential stories from Story 3 to 6 can't be parallelized since they weren't split further. However, the broken down stories will significantly reduce development time and minimize waiting periods. That brings us to the end of this video. If you'd like to support the channel and help us keep making videos like this, you can do so by using the super thanks button below. As always, thank you for watching, and I'll see you in the next one.